Afternoon, class. You're all welcome. Today we're going to be looking at a new topic called sorts. Okay, so sorts. A sort is just a root that is irrational, like this. Okay, we have root 2, root 3, root 5. These are just irrational numbers. Okay, an irrational number. Well, in our next class, I'm going to deal with it extensively. Okay, I'll deal with irrational numbers, but for now, irrational numbers are numbers that cannot be written as ratios. Okay, they cannot be written as ratios, so these are irrational numbers. All right, we're going to see sorts today. Examples of sorts are this. All right, why now if I write root 2, root 2 is equal to 1. If you press your calculator now, it is equal to 1.41 4213 and this continues. Mind you, it continues, though this is the highest the calculator can take. 1 2 3 4 5 6 7 8 9 10 digits. That's all. So the calculator stops here. And if you notice, this number, you cannot predict what comes next. So this is an irrational number, and then it has no end. Okay, it continues indefinitely. Okay, no end, endlessly, right? So we're going to see more of this. But if I write this is exact, this is exact. Okay, this is exact. This is the actual number. It is exact. And this one is its approximation. Okay, this is a rounded off number, rounded off, or approximated. Approximated to how many decimal places? 1 2 3 4 5 6 7 8 9 decimal places. Okay, approximated by your calculator. So rounded off number. This is a rounded off number. Okay, rounded off number, and then this is the exact number. So we will be dealing with the exact numbers rather than the approximated numbers. So we have root 3, root 5, and so on, root 7, root 11, and so on and so forth. These are all sorts. All right, now let's take some examples. Simplifying sorts. All right, let me take a first example. Examples. Number 1, I have simplify. Pay attention, please. Simplify the following. See, we have root 24. B, I have root 75. C, root 98. D, I have root 192. Then E, we have root 768. All right, now in simplifying sorts, you know, I cannot press my calculator. Solution, I cannot just press my calculator to give me square root of 24 is going to be 4 point something something something, 89 something like that, right? I don't need that. It's going to give me a whole lengthy expression, and it's not going to be convenient for my work. So now I'm going to simplify this A. See, all I'm looking for, okay, all I'm looking for is perfect square. You know what we call perfect square? If I look at the number, I can break down the number into prime factors. See? All right, let me take the number first. Let me take it, root 24. Then I'll break it. You know how to break 24 into prime factors. So 24 is the same thing as 2 times another 2 times another 2, then times 3. This would be 24, right? But all I seek is a perfect square. See, the only perfect square I can get here is 2 times 2, right? So 2 times 2 will produce 4, and 4 is a perfect square, and that means that root 24 can be written as square root of 4 times times square root of 6. All right, good. Now, this takes us to one of the rules of Surds. Okay, the rule states that rule 1, I can have root x times root y like this. This is equal to root x times y. See, this is correct. This is correct. But don't make this mistake. Root x plus root y is not equal to root x plus y. Please, a good student should take note of this. Take note of this, okay? This is wrong. This one is wrong. And then this is correct. See that? So when I multiply two similar surds, this and this are similar. If I multiply them, then I can take the square root sign. This is called a root sign, right? Both of the numbers within the square root sign. You get that? That's it. Now, I can go on with this. See? That means that I have root 24 can be written as, now, this and this are the same. If I have this like this, I can reverse it back to this. So that means that I have root 4 times root 6. See? But why am I choosing this perfect square? Because I can take the square root of a perfect square, right? The square root of 4 is 2. I'm going to have 2 root 6 now. This is my final answer. So we apply the same thing to the second one, b. B, we have for b square root of 75. So the square root of 75 would be, now I can break 75 down into prime factors. Now we have 5 times 25. But this can further be broken into 5 times 5 times another 5. See that? Right? Sorry, 5 times 5 times another 5. This is 3, sorry. This is 3, I'm sorry. It's a mistake. This is 3. This is also 3. It's a mistake. All right? All right, 3 times 25 is 75. Then break 25 into 5 times 5. And so you have 3 times 5 times 5. So now, we can see clearly that these two will form a perfect square, right? When I multiply, they are the same. This times this will be 25. So my final answer here is going to be 25 times 3 can be written like this, right? All right. I can now, using that same rule 1, the first rule I gave you, we can have this as square root of 25 times square root of 3. And square root of 25 is what? 5 times root 3. And so this becomes 5 root 3. See that? All right. In C, what do we have for C? Square root of 198. Square root of 198, I seek, square root of 98, not 198. I seek two numbers to multiply and get 98, but the most important thing is to get the biggest perfect square that can get into 98. And I think it's 49, right? But I will not approach it like that. Let me break it down first. 2 times what will give me, because 2 can go in 98, 2 times 49. And so this can now be written, because 49 can be written as 7 times 7. See, that is it. And so we're going to have square root of 49 times 2. And so square root of 49 times square root of 2. And this becomes 7 root 2. No difficulty in this, right? The next one is D. In D we have what? 192. Square root of 192. This would be, okay, how do I break 92? See, 2 can go in 192. How many times? So 2 in 19 is 9. 2 in 12 is 6. So times 2 like this, right? So 96 times 2 will produce 192. Okay, now But I can further break this one into, because 9 can go, 2 can go in 9. How many times? We'll have 4. 2 in 16, how many times? 8. 2 in 16, 8 times. Times 2, times 2. See, I'm breaking this number into prime factors. So this becomes square root of, now 48 can be broken down into parts. Right? Let me just break it into 6 times 8 times 2 times 2. All right? And so this becomes 8 is 2 times 2 times 2. 3 times. This is 3 times 2. So we can have square root of, okay, I have 2 times 2 times 2 here. 2 times 2 times 2 for this 8. And then times 2 times 2. Then I have for 6, 2 times 3. You see that? And then it becomes, this forms a perfect square. These two form a perfect square. These two form a perfect square. And so we have 4 times 4 times 4 here. That would be 64. So that means that we can have 64 times 3. And so we have 64 times 3. I'll break it down. 64 times root 3. And so this becomes, what is the square root of 64? Is 8. 8 root 3. Okay? The last one. I'm going to solve the last one, E. In E, we have square root of 768. Square root of 768. This would be equal to, all right, 2 can obviously go into this number. 2 in 7 is 3. 2 in 16 is 8. 2 in 8 is 4. Then I have times 2 here. So this becomes, all right, 2 can go in this again. 2 in 3 is 1. 2 in 18 is 9. 2 in 4 is 2. Times 2 times 2. See the way I break it down? All right, 2 can go in this again. 2 in 19 is 9. 9. 2 in 19 is 9, right? Then 2 in 12 is 6. So we have 96 here. 96. Then times 2 times 2 times 2. Now 2 can still go in 96. 2 in 96. 2 in 96. 2 in 9. 2 in 9 is 4. 2 in 8 is 2 in 16 is 8. Then times 2 times 2 times 2 times 2. Remember that? Then this is the same thing as, you see, this is 6 times 8 times 2 times 2 times 2 times 2. Right? These 4 numbers. All right. Here we have, this is 3 times 2 times 2 times 2 times 2 for 8. This 8 is this. Then this 6 is this. Then we have these numbers. 2 times 2 times 2 times 2. Right? And so this becomes, how many 2's do I have here? How many pairs will give me a perfect square? Perfect square, 4 times 4 times 4 times 4. 4 times 4 times 4 times 4. That will be 256. So I have 256 times 3. And so my answer becomes 256 makes it 16. All right? Square root of 16 now, right? All right? We have 256 times square root of 3. That means that we have 16 root 3, because the square root of 16 is 3. All right? Square root of 16 is 3. Thank you.